Today we're going to talk about dividing polynomials using synthetic division. And what we've talked about in the past is we've talked about polynomials, and the polynomials that we've actually discussed have been quadratics, anything to the second power, and we've used factoring a lot of times to find the solutions to these quadratics, to find the zeros. However, today what we're going to do is we're going to talk about tools to divide factors out of like cubics and quartics and quintics or something to the sixth degree, instead of just dealing with quadratics. So there's a method that we can use, and it's known as synthetic division right here. And I'm going to go through this method and how it helps you to find out if a factor is a solution to a polynomial. So if you take a look at it, this first one, number 1, says that x squared plus 7x plus 12, and it wants us to divide that by the factor of x plus 4. Now this right here is your factor, okay? Now if you were to actually take and solve for this by setting it equal to 0, x plus 4 is equal to 0, your x value would actually come out to be a negative 4. So when you use synthetic division, what you do is you take that x value, negative 4, and you divide it into this quadratic right here, okay? And to divide it into this quadratic, what you're actually going to do is you're going to look at the leading coefficients. So you're going to look at this 1 right here, this 7, and this 12, and you're going to put those in. So you got 1, you got 7, and you have 12, okay? Now what you do with this is you actually take this first leading coefficient of 1, you go ahead and you bring that down, okay? You then go ahead and you multiply these two things, 4, all right, negative 4 and 1, and when you do that, you end up with a negative 4 here. And now, in this column, you have 7 minus 4, which is going to go ahead and give you 3. And then you take and you multiply these two things. You multiply your x value, and you multiply it by this 3 right here. You're going to end up with negative 12, and then you end up with a 0 here. Okay? Now, this part right here, this last part, this is known as your remainder. Okay? Now, if your remainder is equal to 0, okay, you'll notice that this is what's known as the factor theorem. Okay, a polynomial f of x has a factor, x minus k, if and only if f of k is equal to 0. Well, in this one, your remainder actually turned out to be 0. Okay, so when we divided this, you have a factor of x plus 4. Now this right here, you go ahead and you write it as x, right, plus 3, okay? And then you don't have any remainder here. All right, so when you divide x squared plus 7x plus 12, and you divide it by x plus 4, you come out with an answer of x plus 3. Okay? This one right here, we're going to go ahead and we're going to do the same thing. We're going to use long division to go ahead and divide these two. So your x value in this one is in a positive 1. You take it out, it's in a negative 1. Now your largest exponent, your degree here, is to the 4th power, so we're talking about a quartic. So we're going to take that first coefficient, we're going to write it here, 2. Then you have cubed, so we're going to take the coefficient that's in front of that x cubed, which is negative 1, you're going to write it here. Now you'll notice this one is missing an x squared. There is no x squared. So in the position where x squared would go, we actually put a 0. There is no x to the first power. We're going to put a 0. And then we're going to take our constant, and we're going to put a 4, and we're going to start doing synthetic division to see if this is a factor of this quartic. Okay? So I'm going to follow the same steps. I'm going to bring 2 down, and then I'm going to multiply these two numbers right here to get a negative 2. I'm going to add these together, so I have negative 1 plus a negative 2, which would give me negative 3. I'm going to multiply these two, so I'm going to end up with 3. All right? Add those two together. Multiply, you get negative 3. I have 0 minus 3, which gives me negative 3, so I'm going to multiply those. I'm going to end up with 3 right here, and I end up with a 7 as my last answer here. Okay? Now remember, this right here is my remainder. Okay? And this time, did I get a remainder of 0? Well, I didn't, which means that this right here is not a factor of this quartic. Okay? But when we divided it out, what we end up with here is 2x to the 4th minus x to the 3rd plus 4 divided by x plus 1 is equal to, you start with this, and this is going to be your x to the 3rd power. So you have 2x to the third. And then we just keep working down. X squared, x, and then x to the 0 power. So you have 2x to the third minus 3x squared plus 3x minus 3. All right? And you'll notice that's what you get, but then you also, at the end here, you have a remainder. So you have to add your remainder of 7, and then you divide that by x plus 1. So that also is included within your answer. So I'll actually go ahead, just so we don't create any confusion, I'll erase this right here. Okay? So this is your whole answer right here. And this actually, I apologize, this was not an x plus 7. You put it over this right here. Okay, so you put it over that right there. So it was over x plus 1. Okay, so that's how we use synthetic division. Our hope when we're doing this is that we do end up with remainders of 0, because then we know that these are solutions to these quadratics or cubics. Okay, let's go to the next one. All right, we want to take this quartic right here, and we want to divide it by x minus 7. So I'm going to take my x value out of here, and my x is going to equal 7, and I'm going to use that as my basis to start my synthetic division. Okay, leading coefficient here is a 1, x to the 4th power. Then I'm going to put negative 6. You'll notice I'm missing my x squared term here, so I'm going to put a 0 in its place. And then I'm going to go to minus 40, and then I'm going to end up with 33. Okay, I'm going to bring my 1 down. All right, I'm going to multiply these two things together. I have negative 6 plus 7, which is going to give me 1. I'm going to multiply those two things. I'm going to end up with 7 here. Multiply those two things. I'm going to get 49 here. Add these together. I get 9. Multiply those two, and I end up with 63. And then when I go ahead and add those two together, I end up with a 96. Okay? So what we've realized here is that x minus 7 is not a factor of this. But when we divide them, we end up with x to the third plus x squared plus 7x plus 9. And then we have this remainder over here of 96, and we divide that by x minus 7. Okay? Now, the next ones are a little bit different. They don't just ask us to use synthetic division. What they want us to do is they want us to actually go ahead and factor this polynomial completely. Okay? And I've given you guys the tools to factor quadratics. However, I haven't really given you the tools to factor cubics that look like this. So what we're going to do to factor it completely is we're going to start with synthetic division. I'm going to take this x minus 10, and I know my x value is equal to 10 here. So I'm going to take 10, and I'm going to divide that into this cubic here. Leading coefficient 1, minus 12, 12, and 80. Bring this down. All right, multiply that. Add those two together. Multiply that. All right, add those two together. Multiply that. And I end up with a remainder of 0. So what happened here is you know now that one of these factors is actually x minus 10. Okay? So when we go ahead and we break it up into what's known as factored form, we know that my f of x is actually equal to x minus 10 is one of my factors. Now, what happened here is you got x minus 10 is one of your factors because the remainder is 0. And this, you went ahead and you divided out x minus 10. So this idea turns out to be x squared minus 2x minus 8. Now what we can do is we can actually take and we can factor this even more. And this can get factored into x and x. And your factors of 8, all right, so your factors of 8 are 1 and 8 and 2 and 4. And if you do a positive 2 and a minus 4, you end up with this term in the middle. So we did synthetic division with x minus 10, and then we factored it the old school way, just, guess and check method. And we end up with, I'm going to take and put a plus 2 right here, and I'm going to take and put a minus 4 right here. So in factored form now, it's x minus 10, x plus 2, and it is x minus 4. Okay? So we went ahead and we factored this polynomial completely, all right, and you'll see it broke into 3 separate factors, which makes sense because our leading exponent is 3, which means that there's going to be 3 solutions or zeros. Okay? So this is factored form when you break it into all 3 of its factors. Now, the last one right here takes it even a step further. It says find the zeros. Okay? So not only are we going to take it into factored form, but we're going to go ahead and go a step further and solve for what my x values are. Okay? It tells me a polynomial and 1 0 are given. We know that this -6 right here is a 0 to this. So I'm going to go ahead and I'm going to use synthetic division. I'm going to turn this into a quadratic now. -20 and 24. Bring my 1 down, multiply, add them together, multiply, add them together, and multiply. And we should get a remainder of 0 because we know that that actually is a factor. Okay, it's actually a solution, excuse me. So now this right here, you're left with x squared minus 4x plus 4. Okay, that's what this equals when we have synthetic division. Now, if we wanted to find my zeros, we know right now that in factored form, we have x plus 6. That is what we get from that right there. Let's take this, right, x squared minus 4x plus 4, and let's continue to factor this one. Okay? So if you factor that one now, you're going to be left with x plus 6 is your first factor, and then you're going to get x minus 2 times x minus 2. Okay? So all of my zeros for this one, I got x plus 6 is equal to 0. I got x minus 2 is equal to 0. And I got x minus 2 right here is equal to 0. I get x equals -6. I get x equals 2. And I get x is equal to 2 right here. So your x values for this, all right, are going to be -6. And we end up with 2 2's here. It's a double solution. I don't have to go ahead and write it twice. So I'm just going to go ahead and write my solutions as -6 and 2. Now, again, my leading exponent, my degree is 3, which means I'm going to end up with 3 solutions. But you'll notice one of them is a double solution, which means then, if we were to look at this one, all right, this graph, what happens to it is it comes up and it goes through -6, and then it comes back around and it touches, all right, so you'll notice this graph cuts through here at -6, but then it just goes ahead and it touches here at 2, which is why you have a double solution. Okay? Guys, this is factoring using synthetic division and putting things into factored form and then using the idea of factored form to find your zeros or your solutions for cubics or quartics or quintics. Okay? We'll go through the rational zero theorem coming up, which is going to help us to actually start the process of using synthetic or long division.